let's get started in chapter 16, which is on integrals and vector fields. We will mostly be focusing on the concept of vector fields and how they relate to integrals and such. So first, we're going to talk about vector fields and give you some examples. Simple examples would be like wind or particles moving. So it's like particles flowing or particle flow. I guess that's like flowing since I put an S there. And you can picture it changing, as it maybe goes around a mountain or something, but that's like the velocity may change and speed up. So the longer the arrow, that's your vector, then that's maybe the more, the higher speed it has. And then it can be smaller like this. So that's one example. Another one is gravity. So gravity is a vector field. Electricity type stuff, so you have electric fields. Electromagnetism, so electric fields are magnetic fields. Or magnetism is another example. And we represent that like this. F of x, y, z, and notice that it's a vector, equal to mi plus nj plus pk. And that would, of course, be in 3D. If you leave off the k, then you're looking at more like a 2D case like that. We have m, n, and p are functions of those three variables, x, y, z. And if you're in 2D, of course, it'd just be the plane x, y. Okay, let's look at this. So for example, sketching vector fields. Just a simple kind of case, what it might look like. So sketching a vector field. So suppose you have this one. This is just a simple one. This will be in 2D. Let capital F of x, y equal to x plus y, 3y minus x. And so this is your m, and this would be your n. You can also write that in this form, of course. In that form, just to show you, x plus yi plus 3y minus xj. Okay, find, and this is just basically sketching the vectors. So find f of 1, 0, f of 0, 1, and one more, f of negative 2, 1. And plot. So it'll just be in 2D, and you plot those. And what you do is you use the 1, 0, 0, 1, and negative 2, 1 as your initial point. So use one, well, I'll just say xy. Use xy as the initial. So the vector field, instead of saying the vector can just be at the origin, we're going to say, no, let's put it up where the point starts, and then you calculate the vector. So f of 1, 0 equal to, and substitute in to here, and you just get 1, and that's zeroed out, so negative 1. So you get 1, negative 1. F of 0, 1 would equal, and you do that calculation, you get 1, 3, and you can double check that. F of negative 2, 1, you get negative 1, 5. And make sure you're checking that, substitute these in to here, and verify that. All right, so then we can plot that vector, those vectors in this vector field. So it's just 2D, so draw on your XY plane. And we'll start at negative 1, 1. Well, I'm sorry, we'll start at, it wasn't negative 1, at 1, negative 1. And then you plot that point. So zoom in a little bit here. So 1, negative 1 would start here. Oh, I'm sorry, I'm looking at the wrong thing. Try that again. Okay, so 1, 0 is starting here, and then you go over 1 and then negative 1. So it would just go down like that. Then start at 0, 1, which would be here, and then you go up 1, over 1, and then up 3. Over 1 and up 1, 2, 3. It's not a very interesting vector field, but this is what it would look like. And the other one, you start at negative 1, negative 2, up 1, and you go up, you go to the left 1 and up 5. 1, 2, 3, 4, 5. And that's your vector. So that's all that you would do to plot it. Okay, well, so then from here, you get into three-dimensional vector fields. And the next stage to this is we look at integrating with a vector field. I'll show you this idea. So you have some vector field doing its thing like this, but then we put maybe a path of a particle through that vector field. And maybe that these vectors act on that particle as it's being traced out. And so we're combining the integrals of lines and area and volume. Let's try to do a volume here. And volume with the vector field. And that's where we get all the different theorems and concepts when we are analyzing the graphs and you get different theorems. First one to look at is 16.1, which this is called a line integral, and it's integrating over the line. So we're gonna integrate over the line, and then eventually see how the vector field acts on that. It's like a particle moving on that path. And we'll do that next.